Hey everyone, Bob Crossan, Senior Managing Editor for Water and Waste Digest. For the rest of this year, we've been featuring our WWD top projects every single Tuesday. And today I have with me a bunch of people who are going to talk about an emergency sewer repair project for the Great Lakes Water Authority. I have Steve Zajdel, Senior Project Manager for Inland Water Pollution Control, IWPC. I have Minnie Panicker, Engineer for Great Lakes Water Authority and the Project Manager for this project. I also have Fritz Klingler, President of FK Engineering, and Karen Ridgway, President and Principal Engineer of Applied Science Incorporated. So thank you all for being on the call. I appreciate you taking the time, and congratulations on a top project win this year.
Thank you.
Thank you.
So Minnie, let's start with you with Great Lakes Water Authority. Can you kind of set the stage with this project? Where is it located? What was the project aimed at addressing? The scale of it, and how does that fit into the greater GLWA processes at hand?
This project is part of the GLWA collection system. It is located in the city of Detroit on the west side. GLWA has about 185 miles of trunk sewers and interceptors, and this is one of the major interceptors that we have in the system. In 2016-17, we retained our contractor, Inland Water Pollution Control, to perform a complete condition assessment of the entire collection system. As part of this baseline condition assessment, we found out this major distress, and then we retained Inland Water Pollution Control, ASI, and FKE to come up with the design and construction of the project. I'll have the contractor and the consultants go over the details of the project.
Cool. Yeah, so that leads right into my next question. This interceptor is 2,700 feet long. That's quite long. It's almost half a mile. And the pipe measures over 6 feet in diameter as well. What were the challenges that this size of this pipe posed to rehabilitation?
Steve, you want me to go or you want to?
Well, I'll jump in. Sure. The length as well as other factors all pose the challenge in the repair. Some of the other challenges were the limiting residential neighborhood impacts. Since we were building, since the sewer ran through a residential neighborhood, the limited number of manholes over the sewer for access, flow control was a big issue for a sewer of this size and this long. Speed in which to make the repairs, given the imminent sewer collapse and sewer depths to invert at 40 vertical feet below grade. All this in combination with the 2,700 lineal feet and the 6-foot diameter was a challenge. During the design phase with FK and ASI, some of the repairs considered were CIPP lining, geopolymer lining, and slip lining. Geopolymer lining was chosen, and flow control became the major consideration for moving the project forward.
So from a design standpoint, the biggest challenge initially really was to identify and figure out, excuse me, define the condition. We had some video that had been taken, but the flow was very high, and it was really hard to tell exactly how bad it was. We got in there, we tried to get in there with personnel to measure specifically what the issue was and in order to determine potential repairs. We couldn't get in, flow was just too high. So the first thing that had to be done was to design a flow control program that would allow us to actually get in there with man entry and do some measurements and determine, what options we had. So that's where ASI came in, and Karen, maybe you want to talk a little bit about the flow control. And this is really what it was key initially to even being able to begin to address the problem.
So the Northwest Interceptor reach that needed repair, as Steve said, it runs through a neighborhood in Detroit along the Rouge River. So it has parkland on one side, a neighborhood on another side of the alignment. It runs from Tireman Road down to Warren Road, about a half a mile stretch. And it carries a significant amount of dry weather flow. It's a 6'3" pipe, is the original tunnel, built as tunnel, deep in the floodplain, below the groundwater table. So there's groundwater issues here as well. And the dry weather flow was significant. It fills over half the pipe. So it's really hard to see what's going on in the pipe if the flow is in the pipe. So, you know, pretty soon they were, the team, Inland and FK, were calling me to say, okay, what can we do with this flow so we can inspect the pipe completely and also figure out the right repair method. And then repairs, we need to get rid of the wastewater. It needs to go some other direction so that the workers can get in and do what they need to do. So we basically had two options. One option was to, at Tireman Road, to put in some bypass pumps, plug the sewer, put in some bypass pumps, and pump all the way down a half a mile, a significant amount of flow rate, all the way down to Warren Road, and then put it back in. So we laid that out, and that was a very expensive option. And it had a couple of other wrinkles that were of concern. One was we would need some new shafts to pump out of. You just can't put pumps in little tiny manholes. You couldn't put enough pumps in 1 or 2 manholes. We didn't have, as Steve said, we didn't have a lot of manholes to use. So it would require a new shaft, which is expensive, that costs money. And at Tireman Road, we're in the floodplain, and that area regularly floods. And so if we were to put a pump station there, we'd have to either flood-proof the station or be able to quickly mobilize and pull it out of the floodplain if we had a flood on the Rouge River. So they said, they came back, okay, we don't like that option, come up with something else. So we have a lot of detailed knowledge of the workings of the sewers of Detroit, and we know that there are relief sewers that run between the Southfield sewer and the Northwest Interceptor. And we also knew that if we put a gate just downstream of Joy Road, upstream of Tireman, we could close the sewer and use the in-system storage and also kick the dry weather flow over to the Southfield sewer, where it would then re-enter the Northwest Interceptor many miles downstream. And so I proposed that at one of the meetings, and I thought it would get shut down because it's kind of a new concept for GLWA. It has its own risks. We weren't sure of all the elevations. And also there's CSO outfalls along the Northwest Interceptor, and we don't want to make any CSO. So we put this concept out there, and then we went to work to develop it. We went and we inspected the sewers. We surveyed the elevations to make sure that this would work. And we said, yeah, it can. So that's what GLWA selected. And it was a very novel concept, and it worked great. Inland, to their credit, added a couple of other really good refinements of that. They put a gantry crane on the gate because the gate had to be lowered and raised on a daily basis for them to do their downstream repairs. And so that saved a huge amount of money because they rented a crane and installed it. And they also learned how to operate it along with GLWA operators. They learned how to operate the gate so that when they store and release, they don't make any kind of damaging surges. They smoothly empty the storage to the downstream system, and then they're ready to go the next morning when they want to get back in to continue their work.
Well, then once we had the gate in place, so this is, we're continuing on the design process here, and it was really a slick program that ASI put together to divert flow upstream, really take that out of the picture. For the first time in many, many years, I'm not sure how long, somebody was able to get into the sewer and see the real condition. We got the flow down to about 1 foot deep. And there's a lot of debris, a lot of obstacles in getting in. There was limited access, as Steve had said. But we were able to walk through this section of sewer, only to find that it was much worse than what we had initially thought, that there were sections of the sidewall that we had 6-inch wide cracks, that the sewer was settling, that there were offsets 6 inches. Part of the invert was missing. We had silt and sand coming in from the outside. It truly was on the verge of collapse. So the question then became, well, do we sink a shaft and try to just fix it that way? It was because it was a residential neighborhood, because of some of those challenges, because of the cost. The feeling was, well, we have a good flow control program. Can we get in there and do a repair in place, which would be a lot quicker, cheaper, less disruptive? And essentially, we were able to work with the MDQ, well, Eagle at the time, the state agency that permits this sort of work. And we were able to talk to them about reducing the diameter minimally, and in such a way that we could utilize this flow control program to do it on dry weather days. And so what we were able to do really is, in an emergency standpoint, put steel ribs in the worst of the worst sections to support this collapsing sewer. And that happened within the first several days and weeks to get the very worst of it. Then followed by, once we had some control over that, dewatering in the area to kind of minimize the amount of sands and silts coming into the sewer, dewatering the aquifer outside the sewer. Then grinding down, smoothing some of the offset joints and sewer and cracks, removing debris, and ultimately then designing a fix between the several options Steve talked about, CIPP or slip line or spray line, what was going to be acceptable to DEQ and what was going to work from a practical standpoint.
Yeah. So you guys mentioned quite a few things here that I wanted to touch on just briefly as well. So that included the manhole aspect, and then I also noted in the nomination form that there were 2 flow control chambers built for this project as well. So I was curious, since we're on the topic of flow here and kind of that design aspect, how did these flow control chambers help the project overall, and what considerations did you have to make in creating them and constructing them?
Well, first off, you had to understand the flow pattern in the system and the opportunities that existed for that. So my company has done work for GLWA for years, so we had a pretty good, we had some ideas. Secondly, we needed to really go in the sewers, which we did, and survey the inverts of the CSO outfalls. We had to be very confident that when we close the upstream sewer and use the in-system storage, because these pipes have in-system storage, and then they will steady out at a rate where the flow, instead of going downstream, it's taking a big left-hand turn over to the Southfield sewer. We had to be sure we weren't going to make CSO. And that is what the regulatory agency really needed us to be confident on. And so it took a little bit of diligence on that. And then the very first time that inland threw the gate and closed the gate, we were like, call us, we got to come out there. And we got to stand at the CSO outfall and watch how it performs. Watch the levels come up and make sure that they don't overflow. And so that's what we did. And it worked. And it required, that background knowledge. It required GLWA to also figure out how to monitor the upstream levels and downstream levels, how the gate is opened in a smooth fashion, how it's closed. They figured all of that out. But the other thing that is novel about this is we left the structure there for GLWA to use in the future. That was a big selling point of building these gates. If you put temporary bypass pumps in place, They get installed for the project, they get removed, but this gate remains for GLWA to use in the future whenever they want to get in and inspect any downstream section of sewer.
So as the folks trying to design the repair, you know, we're trying to get a dry sewer. The only way you can spray line a sewer like this is to have a truly dry condition. So the great thing about this flow control program was Joy Road diverted about 90% of the flow over to the Southfield sewer. That was the northern shaft. And then what additional flow was coming in from laterals or from I&I, that was actually pumped around at Tireman. So two flow control shafts, the upper one being the diversion flow control and the lower one being the bypass pumping. So that when this flow control program was in place during dry weather, we essentially had truly a dry sewer. And we were able to get periods of 4 or 5 days a week even, where, you know, we could dry things up, put steel reinforcing in, and spray the sewer and get truly a brand new sewer. It really worked well. And the inland guys just did a fantastic job to make that happen. And it wasn't as easy as I might make it sound, because we were relying on dry weather. So yeah, we had 4 or 5 days here and there. We also had, you know, 1 day here, then wet weather in between, and you know, it was a real challenge. And you know, there were some delays because of that, but in the end, we got a fantastic product.
Yeah. So one of the things I wanted to touch on too was you had talked earlier about the manholes and like kind of the difficulty of getting into the sewer. What kind of role did that play in trying to maintain safety of the workers there? How did you guys approach that aspect of the project?
Well, we're used to working in sewers with 800 to 1,000 feet between manholes. So there was really no new implementation. We just performed the company standards. We always have a top man, of course, somebody in the sewer below. We never lose sight of our men. We're always within voice communication, and you know, we have the proper safety equipment.
Okay.
Once the sewer was dried, once the sewer could be walked, that made everything pretty standard for us.
Gotcha. So you mentioned you mentioned also that this relining of the pipe with this spray or whatnot. Could you talk a little bit about what that process was like? How did you guys obviously had to have the dry sewer, you had to get people inside, and you had to spray. What was that process like? How long did it take? And what's kind of been how has that turned out, I guess, in the end as well?
So that was a challenge. So anytime you're working, you know, during dry weather, you don't want to get too far ahead of yourself with your product, with your rebar. I think one of the key aspects in the design was we incorporated the emergency ribs and lagging to stop any kind of collapse. We incorporated that into the design with FK. And with that, there was reinforcing steel yet. And we worked out a system of installing this reinforcing steel such that we didn't get too far ahead of us, is the best way to put it. We put re-steel from spring line, so to speak, and get to crown. The bottom areas we would put on an as-needed basis, just staying ahead of our spray crews. So that when we came in after a wet weather event, we minimized our cleanup and we got back to spraying as quick as that would allow.
Yeah.
So one of the things that we were looking at when we were initially designing the spray lining was, do we reinforce all of these sections or some of them it was important, as Steve said, to try to incorporate the ribs, because in the worst of the worst areas, the ribs were supporting a collapsing sewer. So really no way to get around that. Other areas were not as bad. We worked with the folks at Milliken at EcoCast to try to determine how to reinforce or whether to reinforce certain sections. And in the end, most of these sections were reinforced with steel. We were concerned about reflective cracking over time because there had been so much ground movement. And I think we all agreed that in any of these areas where there was any indication of ground movement, that we would reinforce, which is not necessarily the standard way that you would install EcoCast. It can be a fully structural lining without reinforcing. But in this case, we wanted to prevent future reflective cracking as a result of ongoing ground relaxation and movement over the coming years. So, and it worked really well. And the way it was staged, as Steve said, minimize the amount of cleaning of re-steel and problems and delays associated with that.
Awesome. And Minnie, from GLWA's perspective, how are things now? Is it working pretty well, I assume?
Yeah, this is a 1929 sewer. Building those two flow control shafts, that's a major enhancement to the system. And it is like renovated now, and I'm hoping it's good for the next 30, 40 years. So I think it's all working well now.
Awesome. Well, thank you all for being with me today, and congratulations again on a top project for 2020. We're really glad that you could take the time to do this video with us. So,
Thank you, Bob.
Thank you, Bob.
Thank you.
Thank you.
and if you want to check out any of our other videos, you can check them all out on Facebook and our website, www.dmag.com.